Picture this. You've built an ESP32-based smart irrigation system that works beautifully in your lab, but the moment you leave your Wi-Fi zone, it's blind and silent. How do you get soil moisture data to your phone while you're traveling, or let multiple farmers view the same dashboard from different villages? That's where MQTT brokers and cloud platforms come into play. They're the communication backbone that takes a local IoT prototype and turns it into a globally accessible, reliable system. In this lesson, I show you exactly what these brokers do, how different platforms compare, and which ones make sense depending on your project's scale and purpose. By the end, you'll know how to select the right broker like an engineer who's building for real-world use, not just a classroom demo. An MQTT broker is like the air traffic controller of IoT messaging. Devices don't talk directly to each other. They all report to the broker, which then routes messages to whoever is subscribed. This makes your system loosely coupled. The devices don't care who is listening, as long as the broker is available. In practice, this means you can have 10 ESP32s publishing data and a dashboard, mobile app, and storage service all subscribing simultaneously without the devices ever knowing about each other. Imagine your devices as airplanes, without a controller, chaos, with a broker, organized flight patterns. Now ask yourself, do you want a local controller in your home or a global one on the cloud? That choice drives everything about your architecture. Local brokers like Mosquitto are lightweight, fast, and excellent for environments where internet isn't guaranteed. Think smart homes or labs. I often spin up Mosquitto on a Raspberry Pi for in-house testing because it's quick, private, and under my control. But here's the catch. Once you need remote access, you're juggling port forwarding, firewalls, and VPNs, and that quickly becomes messy. Cloud brokers like HiveMQ or Adafruit IO solve that by handling security, uptime, and accessibility for you, but at the cost of dependency on an external service. So the trade-off is simple. Local means control and speed, cloud means scale and reach. The trick is knowing which side of that balance your project actually needs. Let's look at the common options side by side. Mosquitto is the workhorse for local networks, lightweight and open source. HiveMQ offers cloud reliability and a free developer tier that's perfect for learning. Adafruit IO is a maker-friendly option with easy dashboards, while ThingSpeak shines in academic projects thanks to MATLAB integration. Firebase doesn't use MQTT by default, but its real-time database syncs well with mobile apps. Finally, AWS IoT Core is enterprise-grade, steep learning curve, but unbeatable if you're building something commercial and large-scale. Think carefully about what your project really demands: fast tinkering, easy dashboards, or production-level infrastructure. Security is where many beginners cut corners, and that's dangerous. I've seen projects where people expose Mosquitto on port 1883 to the open internet. Within days, bots flood it with garbage traffic. Always encrypt with TLS SSL if you go beyond your LAN. Cloud services like HiveMQ and AWS IoT Core enforce this by default, but when running Mosquitto locally, you're responsible for setting it up. Authentication matters too. API keys, certificates, and proper user accounts prevent unauthorized access. Remember, an insecure broker is not just your problem. It can be hijacked as part of wider attacks. The lesson here: treat your MQTT broker like a front door to your house. Would you leave it unlocked? Now let's connect this back to project choices. If I'm building a home automation system for my own house, I keep it simple with Mosquitto locally, no cloud dependency. If I'm mentoring students on data visualization, ThingSpeak or Adafruit IO gets them results fast without heavy setup. For real-world pilots, like an agricultural monitoring system across multiple villages, HiveMQ Cloud is my go-to, because it's reliable, free to start, and handles the messy parts of scaling. And if a client is paying for an industrial deployment, AWS IoT Core is the natural choice, despite the learning curve, because of its integration with analytics and AI services. The takeaway? Match the broker to the project, not the other way around. What you've seen in this lesson is the backbone of real-world IoT. Brokers and platforms that make ESP32 devices more than just local toys. You now understand how brokers route data, why local and cloud approaches differ, and how to evaluate the major options based on project needs. Remember, the right choice balances control, scale, and security, and those decisions define whether your project is just a demo or a deployable solution. As you move forward, keep asking yourself, where does this system need to live, who needs access, and how do I secure it? Answering those questions will guide you to the right broker every time.